And again, we'll have exceptional set of speakers. And before that, as has been customary, I'll introduce the slide this time. Professor Chakravarti is not around, Professor Sen is not around. So I'll take over and just explain the history of the department very quickly. The students are also familiar with, but I'll very quickly run through. So this is, so I'll more talk about the idea of the event. So we started this event series 2 years ago as part of our 25 years of the Silver Jubilee program, which is the MDiS program. The MDiS program started a year before the department started. So that's why we thought it's a good idea to celebrate it over the 2 years. So 97 we started the program, 98 the department started. This is what we started with. We are still there. This is what we hope that we'll get in a year or two. May not exactly look like that, but somewhat very close to that. We will get there. Over the years, of course, the department has had good, it has grown in many ways. We started with largely an MDiS program, and we've become very strong on our design research side. We have started an MTech smart manufacturing in the last 5 years. So that you can see the numbers reflect that. We have always been a small program. Many design schools produce about 450 people a year. We have produced 435 people in 25 years. So that tells you about our number, but that's where it's important to maintain the quality as well. And the quality is, of course, by the students. So it's left to them to decide what they do about it, right? Now, with that, and of course in the research domain we have had good rankings and all. Design awards wise also we have done fairly well. So there are some noted design awards like Red Dot Award, getting mentioned in Times 25 Best Inventions. James Dyson Awards where we have started very well. The first 2 versions of James Dyson Awards, it was from CPDM or now DM. So we have started very strong on the James Dyson side. We have also done very well in the area of startups. So we have had a number of startups. We, of course, because the slides were made once, so these startups get the mention again and again. But over the years, we have more than 15-20 startups. So about 20% of our students now end up in doing startups. So, and we want to sort of continue that legacy and maybe extend that number. Being a strong design research community, being in IISc, of course, research is our bread and butter. So we have also had a number of students who have graduated and gone on to become faculty across many institutes, both in India and overseas. And this is only a representative sample. They are not listed here. It's not an exhaustive list, but you can see that, okay, we have spread our wings across notable design schools in India and across many other schools in other places as well. I'll not repeat these. I think these things are around, but like any other department in IISc, we pursue excellence. What is important is our distinctive focus on looking at a comprehensive way of design. Right? We're looking at functional aesthetics, usability, and sustainability aspects. So each of those 4 pillars are very strong and foundational for us. And being started from an engineering design department and being housed in IISc, we seek, of course, technologically intensive products, eventually, of course, socially impactful. We have a number of major initiatives, 2 dominant conferences, international conferences, one in design, which started, now we are in its 10th version, and this is every 2 years, so the last 20 years, or 9th version. And the more recent conference series is the I4AM, which is for Industry 4.0 and advanced manufacturing. In addition, we have 4 or 5 other initiatives, which is National Design Innovation Network, CFC Smart Factory, one of the 5 across India, a technology business incubator for medtech and geriatric, and then more recently we have started a Center of Excellence on Design, with the aim of teaching 40,000 students in design of the next 4-5 years. That brings us to the agenda. So I was quick at that, so I'll hopefully have recovered some bit of time. The agenda is, of course, known to everyone, so I'll again move on. One of the things I wanted to sort of remind again is that with each of these events, we try to connect with our alumni of that batch. So first event, first batch, second event, second batch. This is the 23rd event, so I'm hoping that some of them from 23rd batch will join. Usually it's only a couple of them, At least one is there right in front, so that's good. I'm hoping that there will be a couple more at least will join, and then. So the idea is they come and talk about what's their journey been since they have graduated. Right, so that's one way to connect with them. After all of these 25 events in January, we do a mega event that will be the closing of all the Silver Jubilee aspects, and that will be 4th of January. We'll be inviting everyone physically, all the speakers who we later on, of course, we call them CPDM or DM ambassadors, invite all the alumni and so on. So we'll hope to that event will be a major event in terms of a get together. So that's been planned for 4th of January. That's the panel for today. Again, I introduce each of them as we go along. And as has been the tradition, I'll start with the people online. So it's easier to get started, break the ice, and then we'll follow on from there. So I'll invite Professor Karmakar to start with his talk. So the format, as you know, is the first 40 minutes is a 10-minute talk by each panelist, and then we'll go into the Q&A and then the panel discussion. So Professor Karmakar, if you have slides, may I request you to please come on camera and share your slides. I'll unshare mine.
Okay.
And while you do that, just give me a couple of minutes so that I can read out. Oops, that was unexpected. Just give me 1 minute. I'll unshare here. Yeah, please go ahead and share your screen. So I'll quickly read out these bio. So Professor Karmakar currently serves as the head of the Department of Design, IIT Guwahati. He has post-PhD 14 years of teaching and research experience. He gained research experience in ergonomics, human factors from DPASP, Defense Research and Development Organization, DRDO. He earned a PhD degree for his work on virtual ergonomics using digital human modeling from Bharatiya University. His research interests span physical ergonomics, cognitive ergonomics, design and work environment, design and occupational health, virtual simulation, etc. Total 11 research scholars have been awarded PhD degrees, and another 8 students are presently pursuing their doctoral research under his guidance. He has published 50 research papers in international journals and 54 research papers in various referred international conference proceedings with ISPN. 1 US patent and 12 Indian patents have been granted for his IPL work. Welcome, Professor Karmakar. Thanks.
Thank you. Thank you for the nice introduction. And can you see my slides?
Yes. Yes, please go ahead. Yeah.
Yeah. So good evening, everyone. And I'm really grateful to Professor Vishal and organizers from IISc Bangalore to giving me this opportunity to present my thoughts and particularly my work related to design. So the topic of today's presentation is user-centered product design and particularly product innovation. So I will continue my talk like this way. First, I will talk about designerly approach, particularly as I come to know that students are also there. So they should know how this approach from design or design schools are different from engineering perspective or from science perspective. And later on, I will discuss about design thinking and double diamond process model. After that, I will go for 2 case studies, one related to product redesigning and another is the new product development. So first I want to mention that what is designerly approach and how our approach, faculty members or students or designers in industry who are dealing with design or designing different types of products and process. So their way of thinking, which is actually known as design thinking, and the process they follow, that is relatively different from other discipline, other stream. So when a problem is given, a problem is identified, if it is for engineering students, as I am from academia, so mainly my discussion will be around the academics only. So students, after getting the problem, if he or she is from mechanical department or production engineering or civil engineering, because we have minor in design program. So in that program, students from other departments, they are also enrolled in for product design minor. So if we give them any problem and tell them, okay, you have to develop some solution for the problem, so they directly jump into the solution because they think that functionality of the product is most important and directly go that how functional product they can develop. But when from the perspective of design we look into, it is very important for us to understand the user. There is no doubt that functionality of the product should be ensured. Now, if we talk about Maslow's hierarchy of needs, then you can see that gradually how the needs are starting from physiological, safety, love, belonging, and finally the self-actualization. So this is the hierarchy of human need. Similar to this human need, if we go to the consumer's need, according to Patrick Jordan, most important is the functionality. If your product, your innovation is not functional, no one is going to accept that one. But if your product is functional but not usable, then again there is problem. So first, being a designer, we have to ensure that our product is functional, and then when it is functional, we have to ensure it is usable. You have to ensure that usability. So here it is important to remember that functionality and usability is not the same. I think all the designers and design students know it very clearly. Just for example, say I have a vehicle, and in that vehicle all the controls are there. The driver can drive the vehicle from one point to another point, and the vehicle is really good in terms of fuel efficiency, in terms of performance. But the driver or the person who is driving, if he is not comfortable, if the controls location, accelerator, brake, clutch, or different other controls are positioned here and there, all are actually functioning, but not properly placed, not properly oriented, and proper human aspect has not been considered, user aspect not considered, then the product cannot be used by the operator or the driver. So there is usability related issues, and that product cannot be successful in the market. So first off, you have to ensure functionality. When the functionality is ensured, then you have to think about the usability. After ensuring the usability, then you have to think that product is functional, product is usable, but which product people will like? Assume there are 2-3 products of same functionality or similar level of usability, but consumers or common people will like that product which is more pleasurable to them, pleasurable in terms of color, form, texture. In aesthetics is playing an important role here. So therefore, according to Patrick Jordan, when you are thinking about the consumer needs, we have to satisfy consumers' needs like this. First, functionality, second level usability, and third is the pleasure through aesthetics. Now, for any of the design process, all of we know that there are basic 4 phases: pre-conceptual phase, conceptual phase, pre-design phase, and detailed design phase. Generally, in pre-conceptual stage, what we do, we try to understand the user. For that purpose, we follow different techniques, user survey, ethnographic study, user study, even different techniques are there. We try to understand the user, their need, and we ask various WH questions. What we are going to design, why you are going to design, how are you going to design, for whom we are going to design. If we get those answers, then it will be very easy for us to understand exactly what we are planning to do. And after understanding that one, we also have to think about the various limits, the constraints we have to set. Because we cannot, although designers should be free to think, designers should be creative in their thinking, but it should not be random. There should be some boundary. Being within that boundary, they should show their creativity, they should come up with out of the box ideas and will give the very unique and appropriate solution. So here the design limit in terms of in which context those products or that solution is going to be used, what the targeted population, physical dimension of the product, what type of material will be suitable, what should the cost constraint, what are the available manufacturing processes to develop that product or manufacture that product, and at the same time we have to think about the sustainability. Now the question is coming, if so many constraints are there, then how designers can create multiple concepts? Yes, it is still possible, because there are, in the next step, if we move to conceptual stage, there are different types of techniques depending on the level of complexity of the product, starting from the very simple product where just brainstorming or some mood board, you can proceed for developing concept. But when we are gradually going to the higher level of complexity, probably we have to take other approaches like morphological chart, Okay, for concept screening factor, so those things are required. So when the concept is ready in the conceptual phase, then we enter for the next phase where we are going for various types of evaluation, ergonomic evaluation in virtual environment. Then we can develop the physical mock-up. We can go for different types of engineering evaluation, material, stress, strain, structure, stability, integrity, and manufacturability. And when all these things are ensured in the pre-design stage, then we are going for the next stage, that is the detailed design phase. In detailed design phase, what we are doing, we are developing the prototype and going for the user testing. And gradually, if it is required, we will go for the modification of the prototype, and finally, we finalize or freeze the at least minimal viable product. So this is the overall process. Now, for the students, I think students are always curious about that what is design thinking and how it is related to other aspects of design process. So here you can see in normal design process, when you're thinking about the design thinking, then empathize in the first phase. So empathize, you understand the user properly. So empathy modeling is very important. Try to understand your user, their need, their expectation, their pain points, and gradually you narrow down or define exactly what problem you are going to solve for those users. There could be multiple problems, but you have to identify exactly which problem should you target so that many of the problems will be automatically sorted out. So you have to very clearly identify that, okay, this is the problem which I should address through my design solution. And that might have some cascading effect on other problems or other issues. And during this define phase, it is important, as I mentioned in the previous slide, that various constraints you define. Then you go for the next phase, that is the ideation. Develop multiple number of ideas, okay, n number of ideas following different types of process, and then gradually narrow down to most feasible, most practical one. And based on that, develop mock-up and prototype. When the prototype is ready, then go for user testing. And based on the user testing and their feedback, again, if you find there are some problem or some issue, again go for ideation, again go for prototype testing. So this design thinking process is an iterative one, not a linear one. Like in other engineering disciplines, students are going and they have some particular idea, okay, I have to develop that product, going to workshop and just starting the work and developing the product. But in case of design, it is important, most important, first understand the background. Who are the user, for whom we are designing, in which context the product is going to be used, what the competitors, what are the market. So all these things are important to understand. So if we superimpose this design thinking model with the double diamond one, so you know the double diamond model, where we are talking about this double diamond, where the first phase is discover, then define, then develop and deliver. So this discover phase is actually from this model that empathize, first understanding the user, their need, their requirement, and gradually you are coming to the defining, mean you are coming to the specific problem and setting some constraint. Based on that constraint or within that boundary, you are going to develop the product. Then you develop numerous concepts. Again, it is diverging. After that, out of the so many concepts, you finalize one concept and gradually develop mock-up and prototype of that. So that is your final solution. So in that way, we need to proceed. Now, I am coming to first case study. First case study is related to product redesign. So the product is already there for a particular activity or particular work scenario, but how we can redesign that product to ensure better occupational health safety, and particularly this product was for stone polishing or floor polishing purposes. Now, workers are exposed to different types of occupational vibration. One of the vibration is while they are operating or using this type of polishing machine. So there are different types of vibrating tools like drill machine, polishing machine, rust cutter. When they are exposed, then due to the vibration, different types of vibration related symptoms are there. And particularly when they are going this type of using this type of handheld polishing machine or this type of bigger polishing machine, which they can operate in standing posture, different types of issues or different types of problems they are facing. So first, and particularly the solution what I am going to talk about, that is related to this one, that handheld polishing machine. So there, first thing, transmission of vibration is there, repetitive strenuous activity it is, then they are holding this heavy load of 3 to 5 kg in their hand for longer duration, and the working hour is 8 to 10 hours, and due to this type of activity, their hand muscles becoming fatty, and also in the long run it leads to irreversible hand injuries. So not only that, if you look at the design is not appropriate according to the human anthropometry, biomechanics, and as per the user other requirement. So the aim of this particular redesign project was to develop an appropriate polishing machine. So here you can see this is the existing polishing machine, which is nothing but the redesigned drill machine or modified drill machine. Now I'm going to show one video how they are right now doing the activity. So they are the weight of the machine they are holding here, getting the support from the thighs or knee, and continuously here operating this one, and during that time vibration is transmitted from this machine to their hand and going to their shoulder and body. Now, first what we try to understand, so obviously I am not going in details, but we are going to try to understand their socio-demographic characteristics, what are the problems they are facing, and finally when we are thinking from the ergonomics perspective or users perspective, then we found that their posture is not comfortable, and according to the one particular ergonomic evaluation technique or posture evaluation that is called REBA, we found that their problem is of high risk level. Now, we went for measurement of the vibration exposure. So we have handheld vibration meter, and with that we measured or quantified the transmission of vibration from the machine to the hand and from the hand to the arm and upper body. We also went for electromyographic study to measure the fatigue while they are operating the existing machine, and at the same time when we develop the new machine. So this is the electromyographic study. Continue. So here you can see we also went for the user study where various aspects came out regarding the user's problem, and at the same time we went for market study, what are the competitive products available in the local market. Then, like normal design process, first we develop the concept, then develop the mock-up, and after mock-up we develop the prototype, and then modification of the prototype, alpha, beta, and finally the minimum viable product. So for the concept development, we followed the morphological chart. I am not going into details. So following morphological chart, we can develop a number of concepts. So out of those concepts, we initially selected these 5 as the feasible concept, and out of these 5 feasible concepts, we chose the best one. So for that purpose, we use the park chart techniques, and following park chart techniques, we identified one of the concept. This is the best one or best feasible for our purpose, which is satisfying so many selection criteria. Then gradually we proceed for developing that product. So this is the existing one. So most important is these are the various components of the existing polishing machine. Here is the new modified one. This is the various components of it. Here it is important to see that in the existing machine, what modification ultimately we did to reduce the vibration. So it is the compound gear in the existing one, the axis of the motor shaft and the stone shaft, that is different. Now, and through the gear it is connected. So what is happening, as those are not on the same axis, always there is generation of vibration and jar, and that's leading to more vibration. But we replace this one. What we did, we come up with planetary gear. So planetary gear and with attached DC motor we use. So now what is happening? The motor axis and at the same time stone axis, polishing stone axis on the same line. So then what is happening? The overall vibration generation has reduced greatly. Now gradually we move for the mock prototype development. You can see. So now I am going to the first prototype. Look at the video.
Kamkar, can we wrap it up in another 2 minutes? Sorry, we are well over the time.
Yeah, fine. Fine. So here, so this is the first prototype, and in that prototype you can see. Okay, fine. I will go for the next slide and then I will explain. So ultimately, what we did initially, the weight was 2.5 kg, but in our case, weight is when we redesign that weight is more. But now as you have seen in the video, so they need not to hold the weight because now it is on the ground. How it is on the ground? There are 3 legs on the device, and the weight of the machine is being borne by these 3 legs, and bottom of those legs there are metallic balls which is allowing it to move very smoothly on the surface, and there is spring mechanism at all these 3 legs, and the spring mechanism is used to what is happening actually when the machine is not, the person or the user is not pushing any force on these handles, then there is some gap between the stone and the polishing floor. There is very minute gap. But when the person is exerting some force on these handles, then here as there is a spring mechanism, so the stone is getting touched with the floor and starting the grinding activity. Further, we also proved from the electromyographic study, vibration study, that the what redesign product we develop, it is to a great extent reduce the vibration transmission. At the same time, muscular fatigue of the operator reduced, hand and mobility become better. And look at this is the final prototype. So they are exerting the force by this both hands, and even we can change the handle from this side to that side, another side, based on the left-handed or right-handed person. And when they are exerting, initially, as I mentioned, that there is some gap between the stone and the floor, but when they are exerting pressure on both the handles, it is getting down and touching the floor. And when they are releasing the force, then due to the spring mechanism at the leg, the stone is shifted from the ground. So thank you, as the time is limited, so I am limiting my case study at 1. So thank you for patience hearing.
Thank you very much. Thank you. Hello. Yeah. Thank you very much. We'll take the questions towards the end. So we'll go through all the panel discussions, and then I'll open up the floor for the Q&A. So with that, and of course, I'm sorry I had to cut the time. We are limited on that. But for all speakers, we definitely plan to bring them back for longer sessions. With that, I'll invite our next speaker, Professor Balaji Kalluri, to sort of share his screen. And while he does that, I'll briefly introduce him. So Balaji Kalluri is a systems engineer turned urban futurist with strong international exposure. He's an assistant professor of environmental studies at Flame University. Earlier, he had a special appointment as head of innovations and senior fellow in Tamil Nadu's e-governance agency, researcher innovation consultant in DBI Denmark, and researcher at Future Cities Lab. He set up a bespoke urban open innovation studio, Kudos, to reimagine and transform the future of urban transition. He's a recipient of several global awards from Denmark's postdoctoral fellowship, Singapore Ministry of Education doctoral scholarship, and redefining education through creativity in India, awarded by the Council of for Creative Education Finland. He holds a PhD from NUS Singapore, Masters in Microelectronics Engineering from BITS Pilani, and a Bachelor's in ECE Anna University. So, Balaji, all yours.
Yeah, thank you, Vishal. I'm trying to share my screen, but I find a little bit challenging. Can you guys see my screen or no?
I think we
yes,
can see your screen.
I can see the screen.
Yeah,
I can hear you, Vishal. But can you see my screen?
We can see your screen, but right now we are seeing the Teams screen rather than your slides.
Okay. I'm also trying to figure out how can I see both while I speak, also the screen as well as the deck.
So that will be possible. Okay, so it is
that will not be possible in Teams. Okay. Okay. Never mind.
Open the PPT and.
All right. I'll do that. Thanks for letting me know, Dr. Karmakar. Can you now see my screen?
Yes.
No? Okay, perfect. Thank you so much for the nice little introduction about me. And first of all, thank you so much, Vishal, for extending the warm invitation. And I'm not unlike many of you guys. In the series of these colloquiums and panel discussions that you're hosting. I'm not really trained in design as some of you guys are, but nevertheless, I would try to at least share a 2 cents of some interesting work that I am doing, which has got design, inspirations from design, so. And I'm also not going to, the talk is also not structured in a way that it is going to take through the foundation, but it's going to be more like a lightning talk where I'm going to jump into the actuals of the kind of, stuff that I have designed. And as you can see from the title, I have been exploring and using design, specifically, the serious games in shaping the future transition of, cities in Global South. And that's what I'm going to talk in the next 10 minutes or so. Now, why do we study about urban futures, and why do we, need different disciplines to think and shape the future of cities? And here are some reasons why we should be, really as a design community, and also, globally, all other different disciplines should, in my view, work together to shape the future of cities. And first and foremost, I'm pulling some, reports from global megatrends, which shows what are the problems concerning humanity in the 21st century, especially in the next 20-30 years. And it points to various global megatrends. There are 15 in specific. One of them is urbanization, and it is one of the complex challenges to solve. And and it is also informing how do social settlements develop, develop and house a lot of different activities concerning society as well as economy and so on and so forth. Right now, it is also important. Often people treat urban design and urban shaping the futures and transition pathways of cities is really a complex and wicked problem involving a lot of different actors and holding different powers structure, and also different society and the social demography and so on and so forth. And therefore, it is really difficult and challenging problem to deal with. And therefore, I'll resort to the tool that we have considered to use and shape this. Number three, the report also talks about it is actually in cities. Cities are actually the places where some of the greatest challenges of the millennium are going to be solved. And therefore, it is very important to shape the cities. And it is believed in urban design that cities are in turn going to shape human beings and the society as well as the humanity as such. So, and of course, I'm going to also shed some light on the context of urban futures and and Global South and their relationship, right? So the future studies also indicates that among the top 10 most populated cities, which is what we call urbanization as one of the mega trend, you can observe from this reports that by the end of this century there are going to be two most populated cities across the world. India is going to hold two of them, Mumbai and Delhi. No surprises on that. But what you can also observe is most of the other cities are also, populated cities are going to be in Global South, and therefore it is some of the problems what we are going to address, or the tools that I have designed is somewhat common, and it entails shaping the problems and problems concerning the Global South communities. So urbanization, as I said, will occur mostly in the Global South, and it will be, India is home to about majority of the world's biggest cities by the end of the century, right? And now, shifting gears and departing from that context of urban South, urban futures, and Global South, and why it is important to connect it and guiding the pathway of the development of our country, right? So here are some food for thought for us. So we are in 2024, and it's important to devise strategy alongside the national goals and ambitions. So we are racing towards 100 years of independence, and as nation, Viksit Bharat is an ambitious goal, and we see India is on the course and of becoming one of the third most populated, rather not populated, but most economical powerhouse of the world, and that is our ambition to become $35 trillion economy. Of course, it is going to be challenged by a lot of different disasters and risks along the journey in the next 20-25 years, right? And you can see a lot of money and investments and economy is going into preparedness and recovery and from these various disasters, which is both climatic as well as other forms of natural and man-made disasters, right? So here is a first challenge that I'm posing, which is challenging the ambition of the country. Now, another second most important challenge that I would like to draw your attention to is the fact that the recent economic survey points to the fact that about only 50% or 51% of our youth and working population coming out of the colleges and universities are really prepared to take up jobs and are really skilled to take and contribute to the economy, right? And this is somewhat similar to many other economies also. Not just the numbers, but the trends are indicating that workforce are not really equipped. And you can see the fact that there is a lot of different transitions in the society, including technology, that is actually rapidly changing, and therefore it is difficult to cope up with this change. Right. So I'm just presenting that there are two different challenges, that is ahead of us if we are, on the course of achieving this ambitious goal. Now, recently, I don't know how many of you are familiar. Earlier this year in April, our Prime Minister Modi has invited a bunch of young, gamers, to have a discussion. These are the top gamers in the country. And he had a very candid, close conversation with some of them. And I would like to, play a little bit of episode for you.
The sound is not really coming well. If you can increase the volume.
Okay, just a minute. Do you think it can play? The volume can play from this video? Is it the embedded videos?
No, I think you needed to change the setting to have the computer audio added to it. If you have not done that, probably it will not. Yeah.
Oh, but you cannot at all hear it, is it?
No, we can't. Yeah. So I think you can move ahead with the message. That's okay.
Okay, fine.
Please.
Okay, so so the message here is among many other things that he talks in this 30 minutes. He brings to the point that how India can become a global powerhouse in terms of gaming industry. And this is a message that he wants to communicate, and especially using games as tools to drive change. And he mentions in the 1-2 minute, excerpt from this entire interview with the young gamers that, we need to not just look at games for entertainment, but games beyond entertainment. And as you know, India's mission is also on the life and environment, the Panchamrit and net zero ambition. So these are some of the really pressing challenges and hard challenges to tackle with, and he is inspiring gamers to really consider looking at gamifying and building these tools to actually inspire kids and also the society to shape, right? So that's a message from this particular video that I would like to share with you. Now, what I have been doing even before this message came early this year is, since as a faculty in Flame, I have been looking and exploring games as serious social innovation tools to drive the change from bottom of the pyramid in the society, and to basically bring futures literacy through games. And games has got a really as some of you know, that it has the potential to bring cohesion and collaboration and so on and so forth, to understand some of these complex problems very closely, and empathize with some of these challenges that society face, and to be part of the solution and not being part of the problem, right? So UNESCO also acknowledges the fact that futures literacy is a really important skill to have among us in this 21st century, especially to be able to prepare, recover, and reinvent ourselves, to build resiliency into the community in the face of a lot of in the face of challenges that we will face in this particular century.
Yeah, Balaji, I just wanted to.
Okay, just
yeah. So I just wanted to alert you that we are almost at time. So if you can take 3 to 5 minutes to.
Yes. So I'm done. So I'm jumping with that background and motivation for why we need to study and use games as tools to reimagine urban futures. What I've done, as I said before, in the last 12-14 months or so, I've designed a suite of tools to which I call it as Urban Excel, right? and I will just skip this. I'm sure some of you know what is serious games. So I'm going to jump directly onto Urban Excel, which is a populated suite of experiential tools, which fundamentally I started bringing the comprehension of the complexity and wickedness of some of these future problems and pressing social problems into my classroom to inspire and ignite thinking, critical thinking and reasoning and futurist literacy among my children in the classroom. And that's how I started with designing them at first place. So currently, as you can see, it entails 4 tools in different scales. The first one is called Prospera in this. Prospera is, I'll go to it. So Prospera is number 1. Number 2 is BIBO or Building in a Box. It's an acronym for building. And third one is called City Runner. And the fourth one is called Site Flash. So each of them are different, but everything together are, in a sense, connects to urban futures and driving literacy through the through the ability of gameplay and collaboration. And all these games are collaborative games. First one talks about educating the futures literacy as far as urban design. So what means future cities and what are the challenges? How do we make decisions? In designing cities of the future is something that this Prospera educates about. Number 2, Bibo talks or educates particularly about the complexity surrounding building construction and life cycle. So we have gamified that through a board game. Third one, and the most complex among all the games here, is City Runner. And the idea about this game is to drive active citizenship, among everyone in the society to be part of, shaping the governance and governing the cities. Cities as systems are a really complex unit, and so there are different actors, as I said before. So it's a really complex system to understand and to shape. So the idea of this game is to drive active participation and citizenship among youth and professionals and also citizens in the country. And the fourth one game is cyber security, to build cyber resiliency into the digital transformation or digital transition of urban systems, especially critical infrastructures. So I'll just quickly take you through glimpses of what are these tools look like for you to comprehend it. So the first one, Prospera, as I said before, has got this is a baseboard on the left. It's a city or a map of a Pune metropolitan city. As you can see, it has got a basic land pattern information on that. And the gameplay, it's a collaborative gameplay with multiplayers, and it's a facilitated game with different future scenarios from economy, social aspects, as well as from environmental aspects that are facilitated to change the course of the game in terms of making decisions for guiding the urban design of the future. Right, and the second game, as I said before, was Building in a Box. It's or BIBO, and it's again a board game which has the picture on the right hand side shows you the baseboard, which has got 4 levels of building. You can see it mimics a site of a construction with 4 levels, and it accompanies a bunch of 37 cards. And the 4 levels in this design embeds the design principles of. It represents 4 core functions that building as a system in a society delivers. It is a shelter. It's also delivers some function and operation. It also drives productivity, and also it impacts sustainability and environment. And that's now the functions, and also there are 4 key stakeholders concerning building construction or building as a unit in an urban environment. So it aims to educate how do we design buildings for accompanying or encompassing these 4 stakeholders and the needs. And the third important principle is educates the life cycle of the building construction through a game. And the whole idea of this, based on my multidisciplinary education and training, is that seldom this entire training about training and the trade and the profession of building construction is predominantly dominated by architects and civil engineers. And what I see to shape the future of buildings, which is becoming a really complex system by itself, because we are putting a lot of technology, which is bringing in and inviting a lot of new risks into the environment, and there are different industries that are also shaping this future of this. So what I see is this knowledge has to be democratized beyond architectural discipline and also the civil engineers. So the whole idea of this is, can we break this entire disciplinary thing to and open it for everyone to comprehend what is this entire industry about? Can we shape the future and innovation pathways in this industry through a simple game in a matter of 30 minutes or 1 hour. So the third and the complex game, as I said before, is a future of transforming the future of governance and cities in India. And of course, I got this inspiration fundamentally by the fact that none of the cities in India features in global livability index. And I have lived in Denmark, and I'm sure Vishal has lived in Finland, and he has experienced how cities are built there. So fundamentally, it is to do with actors, and there are political power, there is bureaucracy, administration, civic participation, NGOs, contractors. So each of them as actors play a critical role in shaping the governance and in turn the quality of life of cities. So this game educates about what controls the quality of life, and as a game objective is together how do we build in collaboration between different actors in the society to control and steer the quality of life of our own cities. So that is the whole idea about this game. So it's a collaborative gameplay thing. And the fourth one, the final one, is it educates 11 key foundational concepts underlying cybersecurity. If some of you know about technology and cybersecurity, CIA, confidentiality, integrity, availability, people, process, technology, assets, risks, vulnerability, threats, etc. So there are 11 concepts. We try to design all that into an interactive ice-breaking game, and we built a complete module on cybersecurity training. In a matter of 2 hours, you can start with this game as icebreaker using flashcards, and go at the end really conduct a risk assessment of a critical urban infrastructure like an airport. And what I want to close saying is I've been in the last 12 years since its design and development, I've been taking and carrying it all over the world, and these are some of the deployments that I've done, including a recent training in with Indian Army to educate them on shaping the future of cantonment into net zero in Jhansi in early this year. And I've also very recently, the games were deployed as environmental leadership tool in training engineers in Cambridge in a recent summer school. That's besides many other deployments that I've had done in the past. So what I wanted to communicate as a closing one is it also is timely. It synergizes the power of game synergizes well with various traits that NEP New Education Policy 2020 enforces. It is about raising a lot of these 21st century skills. Some of them are listed here, and also importantly to shape the future pathways and to bring the social participation to drive and meet the ambitious goals of the nation. We need to raise a scientific temper and bring youth and the working population. That's what we call, which is one of the fundamental thing in Article 51A heads talks about in the Indian Constitution, which is the fundamental citizenship. So how do we forge citizenship? How do we bring participation to drive a really big democratic country like us through education and tools like this is what I see as a future of this, and it synergizes well with this. And my closing note is I am onto this course of taking this, and I'm carrying this bold vision of how can we make these kind of, tools reach every home, every street corner where people start playing and appreciating and embracing and critically thinking and taking active participation and into the national development pathways, right? In whatever capacities and careers that they can aspire to to contribute to. So with that, I think I have concluded with my talk, and appreciate your patience.
Thank you, Balaji. Thanks. Thanks again. A lot to wrap up in 10 minutes, which of course is difficult. But that's the other objective. We keep telling our students make a presentation in 10 minutes, and they always exceed. And we ask experts to do that, and they also exceed. So we have a problem here, right? But that's okay. All right. So I will take, as I said, we'll take the questions later. So with that, I'll move on to our next speaker, and a prolific inventor with 115 patents. So let me introduce him. So we have Mr. Venkatesh Prasad, the senior consultant and head of mechanical engineering and design at TCS. 31 years of mechanical engineering design manufacturing experience with core strengths in precision engineering, his strength, 130 new products that is worked on. As I said, 115 patents filed, 30 plus published and 35 plus granted till date. 90% of them as prime inventor. He's got numerous awards. I'm not going to list all of them. CII award for design excellence, first position, Tata Innovista Award first in entire Tata Group, TCS Innovista Award 2 times for design excellence, Patent Champion Award for 2 years, first prize winner in Hexagon International Conference, and so on. 5 papers published as well. So rather than me listing his illustrious achievements, I'd rather ask him to talk about his work. So I'll share the slides. Just give me 1 minute.
First of all, thanks to Professor Vishal and Department of Design and Manufacturing for giving me this opportunity to share my learnings and experiences to the brightest minds in India, design minds.
We don't mind at all. We don't mind.
So, my engineering background is industrial engineering. I'm not a designer, but over the experience, my passion to design made this all happen. Or I would like to share some tips for the engineers. Yeah. So I would like to share some tips that I learned over time. Basically, I think NPD process I did not teach. So you already, you are the experts, you know all the processes, but I would like to stress on some of the aspects. The DFX principles, the design standards, handbooks, the 2 components of the design and, manufacturing. So you have studied all this, you will be using all this in your design handbooks, CMTI handbooks, machinery handbooks, all those. So these are fundamental things, and to do a good design, you need to have all these, in your fingertips. And not only design aspects, but the material, the manufacturing. So material, we have different forms of material, when to use which material, what are the different, forms of materials to be used, what are the, platings, coatings, machining aspects. All these are fundamental things that you need to imbibe and start implementing in your designs. So that's one thing. I'd like to say the manufacturing process knowledge is very important, because you may be doing designs like, the way I have come up with, like, I have not only designed, but every part that I made. So I have gone to the shop floor and see how it gets made, every step of manufacturing. So that made me a better engineer over time. So the reason being, you will find for yourself what is the mistakes you've done in the what you could have done better in your design, so that the manufacturing is taken care, how the part is held, what are the accessibility issues for the tools of manufacturing. So these are the aspects that you should force yourself to get accustomed to. So another aspect, that's the process development. So the design and the process, right? So you need to be able to develop the process, not only the design. So that knowledge gives you for mass manufacturing. Your product has to go for manufacturing. So that's also important. And then exposure, you need to develop exposures. So why I'm telling this is the technology is changing, manufacturing technology is changing every moment. So 10 years back or 15 years, when water jet cutting was introduced, I went to an expo, I saw water jet cutting. So it can cut this thick, this thick material, right? Laser cutting can cut only 6 mm or 12 mm, the limitation. So, but there was a problem. The 3-axis water jet cutting machine had a taper, right? It was creating a taper. So then you had to do one more process. So after 2 years, I went to another expo, another manufacturer was there who built a machine who removed the taper. So he had a fourth axis probably in the water jet cutting. So the taper was eliminated. So these are the learnings you gain when you visit expos. So that I have been meticulously following. Even today I go to expos, whether it's IMTEX in India or IMTS in US, design to part show, like that. So these are my experiences. And then one most important thing is whatever you design, you have to connect with the suppliers who is going to manufacture it, because they give feedbacks. So you have to build a good relationship with suppliers. And then yeah. So one another thing is, so diverse products, diversify your products of experience. The way you can see some of the things I've listed here, the images are shown here. So every product was a different experience for me, and not only the width of your design, but also the depth. You need to convert every design into a product, right? So that's the key message I wanted to give in this slide. So your foundation to design and manufacturing lies with you, and then you need to have an engineering mindset. Given any product, you should be able to make it happen. Make it happen, right? So that approach, design approach, you should have, and then and the experiences that you learn and keep doing, practicing, will make it happen, right? So some case studies I will show. No problem. So this is one of the latest product that I did. So the problem statement is always not clearly defined, right? So I got this was done some 7-8 years back by me. So the problem statement was, my lead called me and told me, we would like to design a mobile manipulator or to test our robotic algorithms. I want you to design something like a lab prototype, maybe out of aluminum extrusions, simple vehicle to test our software. So that was a requirement, but it's up to you how you want to take it forward. You want to make it industry ready, or you just want to satisfy the need. That's the thing, Then I looked at it. There are two things. One is mobility in this vehicle, plus you can see the video. The mobility plus the applications. Applications are infinite, If you put a robot on top of it with the grippers, you can do infinite, countless applications. So similarly, you can lift and carry the load. You can tuck heavy loads. So like that. So these are the questions I asked. Can we split the function? Can we make it modular? Can we make it most versatile? So then you do benchmarking and you identify what the supplier others are doing and how different you can do, like that. And of course, you have to understand industry problems. You have to do research and all that, right? Human errors, what are the advantages you want to give in your robot. So just next slide. Yeah. Okay. So these are the different applications I designed. What I want to highlight in this case study is there's a robot on top of it. Dynamic forces are there. You need a heavy vehicle. Typically, robots are fixed to the ground, bolted. So you need a very high stability. So the second one is lift and rotate, lifting application. So you need to make the vehicle very light so that you can carry more load and transport more load. And so there is a conflicting requirement, right? So the third one is like a sugarcane. You would have seen tractors carrying sugar, tugging, and often the front wheel lifts. So you need front heaviness, right? So how do you do a design with all the three things considered? That's innovation. So that's what I did. So next slide. Yeah. So not only the innovation part, modularity. So you need to make your product less parts. You need how to make it less parts. When I saw the competitor products, they were all structural. They were weldments. Typically, robotics people, they don't focus on design. They are focused on software. So to make this ready, so I made a monolithic casting design that you can see. And all the parts on sitting on this casting. So the benefit, it's not like an automotive product. This product is not having huge volumes. So you have to do the trade-offs. So you have to say requirements per month is 1,000 per month, right? So some customers will have 20 robots in their factory. Some will be having 50. So if you have 1,000 varieties, I mean 100 varieties, you can't do it. So the base vehicle is you make 1,000, but application wise, the applicant, top units you make as you need. So that was the approach strategy. I did some examples of them. Next. So the key takeaway from the previous slide was, you should give more with less. Yeah, this is the latest vehicle that I did. I designed hands-on, and it has been manufactured by our Tata group of companies. The product was developed. It is the customer requirement was to for two applications mainly. This is to lift the carts and the pallets. So when I researched, there were no vehicles in which were suiting both, except some were there, but they were not compact. So the another need was space constraint. So this is a vehicle I did. You can see the competitor products. We can go to next slides. So what I want to show you is the outer design and the inner design. So again, I'm not a designer, but still with a creative team, there were some designers in our group. So the designers come out. So this is a robot, right? So it's a collaborative robot to work with humans. So when it has to work with humans, it should be pleasing. So we put a smiley face there. And then again, it has to be scary also. So because you don't want humans to come too close to it. So we put the eyes little scary. So then 25 different eyes combination were done. And then communication, right? It has to communicate the LEDs. When the vehicle is going front, reverse, left, right, all these LEDs were animated. So expressive, it should be communication. So this is one aspect. And the other aspect is the internal design, which, okay. So another aspect is the internal design. So you can see how complex it is. So this kind of work is unique design across the globe, and it's patented by me. And it is able to lift 500 kg each fork, so total 1 ton load it can lift. We spec'd it for 800 kg. So that you can see, imagine how much complex design it is. So it is having a long lead screw. It's similar to screw jack mechanism with a motor. So that what I'm trying to stress here is the selection of materials, the process, case carburizing steel, or the bronze nuts or the stainless steel nuts, the torque, the friction. You have to reduce the friction. When the links are like this, the torque is infinite. So what's the starting angle? What is the complete engineering was done. So I put a statement: inventor never sleeps there, because because I never slept for 3 weeks. I mean, I slept for after 3 weeks. I got this idea. I was thinking. Finally, this idea. So when I got this idea, I didn't sleep. Whole night I worked and developed this idea. So that's the thing. And then of course, one point I want to ask. If you observe, there are 4 screws in the one shaft, right? So there's a left-hand screw, there's a right-hand screw. Sorry. Yeah. So there are 4 screws in one shaft. One is left hand, one is right hand. One is left hand. Now, how do you put, this left hand nut, how do you pass it through right hand? So I just like to post it to the students as a question, so that they can think and get back to me with the answer. So how do you put this? I mean, all the pitch of this thread is same, 4 mm pitch, because for every revolution, you want the nut to move same distance. But how do you pass it? So that's a question. Please think over and tell me. Okay. While I move to the next slide. Yeah, this is all the process. What I showed you is innovation, concept design, all is fine, but you need to optimize it. So that is by the process, right? The analytical engineering calculations and design optimizations. We did all that, and the additional new thing that I learned. So every design for me is from scratch. I would not have done previous. Something I would be innovating new. This vehicle design was new to me. So, but the methodology and the research, all help to make it happen. So multi-body dynamics and all. Next slide, sir. So this, I think 2 minutes. Okay. So yeah. So this is problems don't come sometimes, right? You have to create your own problem statements. This is one example. So I used to travel to Whitefield office by metro. Metro was just coming. Before that, I used to travel by train. I didn't get a seat. I invented a seat for me, which I can carry in my back. Second, when metro came, they allowed electric vehicles. So I thought, why not I design a vehicle? So I did this vehicle, and that's my daughter riding it. I think the video is bad. Anyway, so I did this design as a hobby. And then, so after that I wanted to improve it. I didn't have funding, so I purchased a vehicle from US. That's a compact vehicle with the intent that I will use it for metro, but now the rush is so much I can't carry it. Okay, so next slide, last slide. So this is another thing I did in COVID. So again, no one gave this problem. So I had to wash, we all had to wash, probably most of us had to wash the utensils because housemaid was not available, right? So that, probably I also learned washing, washing, rinsing, soaping, all that. Then I thought, how can we improve this? So washing machines are there, but they're not suitable for Indian conditions. So that's made me to invent this product. So I think, I'd like to end here, and we'll look for some questions. Later we can open this product and see. Thank you.
Right, as we said, we'll take the questions in the end. I'm sure there's plenty of questions. And of course, this is a demo. That's not, as he said, it's not his product, but it's very inspired from the idea and the project it's worked on. So we'll look at that. We'll now, and I'm glad that there are a lot of issues that we talk to students about detailing, about engineering, material, and it all builds very well. Now, since I've talked about material and building, naturally, naturally we have Professor Balaji here, Professor SVK as we commonly know him. So he obtained his BTech from the Government Engineering College, Thrissur, and ME and PhD from IISc. He carried out postdoctoral research at IISc and was a guest researcher at the NIST, USA. He has been at IISc since 1997 and is today a senior professor at IISc. Sustainability and how to reach sustainable development has been his passion, and his research has always kept these goals in mind. His approach has been to develop a closed loop cycle of the use of materials. His research into tribology, friction stir welding, processing, metal forming, and development of eco-friendly lubricants is geared towards reaching sustainable development. He's published over 200 peer-reviewed journal articles and chapters in books, and 135 conference presentations and papers. Authored course on material science for the NPTEL program. He's on the editorial board of a number of journals, the top ones in tribology that you can list. I'm not going to list them for you, and you can check his profile, of course. And is also on the editorial board of Wear and Tear and ASME Journal of Tribology. He's also published a book, Liberation Through Education. So with that, I invite Professor Kalluri. Okay.
I can't share my thing, right?
No, yeah, but I'll do that. Start.
Okay. Thank you. I think each speaker was given 10 minutes, but totally they have exceeded 45 minutes. I think more than 45 minutes. 1 hour 15 minutes. So strictly speaking, I don't have to speak. Vishal invited me, but in his mail he didn't tell where the meeting was. I figured out it will be here. And while entering, he says, Satish, where is your presentation? What presentation? So what I have thrashed in here in the last 15 minutes is, I'm not listening to the talk, so I think what to talk here, So whatever, pardon me for any shortcomings in this presentation.
Just give me 1 minute, I'll share it on.
Where is it?
Oh no, that's okay. It's already shared, so I can do it.
They're able to see it. Just make it.
Okay, so my presentation is actually on material design and mechanical design and selection of materials. This is actually a gist of my course that I should teach here. But I can't do that in 10 minutes in any case. So I have made it short, very short, okay, and no part of material selection. So what is mechanical design? I'm sure you have heard all the speakers speak, and the problem with mechanical design is like philosophy. You know? So you go to the church and hear the pastor speak about the Bible, you think it's the greatest text. Then you go to the mosque and you hear the mullah speak, you feel it is the greatest text, and then when you hear Bhagavad Gita from there, you think that's the greatest text. Now, which one to follow? So, the whole thing is finally you are going to go, you are all going to pray to this one God if you believe in that, and finally you are going to go horizontal only. And so all those things don't matter. Even design philosophy, there's several philosophies of design. Next slide, please. So design philosophy, I think you have to click. Just go to the last one. So what I would say to students is that like I just told you, there are several philosophies of design, and the important thing is you read. Continue reading, but don't practice design. Don't practice the philosophy. It's very important to realize where you should practice. For example, in life itself, you say one of the ways to make friends is to have a smiling face. If you have a gruff face, and then it becomes a problem, you don't make friends easily. But then if you go to a place where there is some death, you can't keep smiling. You have to be serious. So don't follow this philosophy everywhere. Same thing with design. There are several philosophies, and each product has some criticality in that particular product which you must follow. So read it, make it a habit, analyze it, make it a habit, imbibe it. This becomes a habit, and practice will come involved. And this, I think, is the whole thing about design philosophy. Make it, when you think about it, think about it. Next slide, please. Yeah, you can go to the last part of this. So there are several design approaches. So functionality, manufacture, assembly, disassembly, simplicity, you can name it, many things, and finally, of course, disposal and recycling. Now, which one do you follow? The point is, you should know each and every meaning of each and every of these approaches, and keep reading it as a designer first thing in the morning. Spend 5 minutes or 10 minutes reading about it. And slowly this will go into your mind. So when you start design, you will realize that you involuntarily follow most of these things, if not everything. And that is critical in design. It's just like life approaches and skill. There are several life approaches and skill. You can keep on writing many more. The next slide, please. Oh yeah, you have not come to the last. No. So you can see here. Oh, there's lots to learn. Yeah. So there are lots of these things that you need to write down and say it, and keep reading it. Keep reading. Next slide, please. Yeah. So all these things are also important in life skills. But for example, you need discipline. But then when you, let's say, go for a party, I think you can keep aside some discipline and enjoy the party. And there are exercise. You not have to do exercise every day. You need other things that you keep practicing it, understanding this is the way I would lead my life, and slowly it comes. It's not something that comes overnight. Maybe it will not come in your whole lifetime, but it is a progress that you will have throughout your lifetime. Next slide, please. So what is a product? This is already told by our first speaker, Karmakar, but I would reiterate it, saying that it should have a useful functionality, should have high reliability, should have satisfying aesthetics, and should have reasonable cost. So next slide, please. So when you say good functionality, you should realize that it should save time and effort. If it doesn't save time and doesn't reduce the effort, the functionality is always limited. I give an example of this dosa batter making machine. There was once this thing that was made in Coimbatore where you could grind atta But the problem was it was make good art, but the problem with that machine was cleaning time was excessive. As long as you had a maid in the house, it's fine, but as long as you're not working or your wife is not working, then it is fine. But when you are running and every minute needs a lot of what you call important, then it's almost difficult. It takes about 20 minutes to clean this machine. So that becomes a problem there. So finally, everything should have good functionality, and in the sense that it should save time and effort and a lot of these other factors that come in there. And also today's product should give you higher dopamine levels. And reliability, of course, I shouldn't be speaking about it. Aesthetics, all of you know what it is. Next slide, please. So if I go into this, all of this, I would not go into the whole details, but number 7 is the best, where you balance all these things. Okay, next slide, please. So if I put it in a cubic form, then when you talk of cost, functionality, and reliability, you should try to go to this top part of this cube. And functionality is something that you can, any engineer can do it. You don't have to be a mechanical engineer. You don't need to know things. But when you want to build reliability into the system, analysis, mathematics, design criteria become very critical. Their fundamentals are very critical. And of course, cost, you need to keep the cost at a minimum. Next slide, please. So if it is an existing product, you need to have a functional improvement and should be significant. Reliability should be significantly better, and aesthetic should be very different and appealing. So if you have a low reliability product, you can sell it for some time in the market, like most of these good old Chinese products. You buy toys for the children. When my kids were small, if you buy for 10 rupees, it will last for 10 minutes. You understand? But they are happy. So that's about it. You don't want it to last for 50 years, 20 years. So that is important. And but then you can really see that at some point you will start losing market. Next slide, please. So a new threshold of functionality has to be crossed, and threshold of reliability and aesthetics has to be crossed. And the important thing to realize in today's products, this time frame has reduced from a few weeks to a few months. Good old days when, not me, even my generation, not 10 years before me, when you completed engineering, they would say you develop one product. It has a lifetime of 36 years. I don't know where they got the number. So then you have made your life. But today it is not that. Products keep changing and changing and changing, and you have to realize that. You cannot make one product and expect it to sell forever. So I put this in a diagram over here. Next slide, please. Just click everything. Next. So you need to, one more. And you need to see that the what you call the functionality and reliability keeps improving over a period of time, and you will reach a threshold where you need to either change the design or change the functionality itself to not make a better functional device. So it's time to leave the market at that point of time. And you should realize for any design, a minimum time has to be. And this is one of the mistakes many of us students make. They do a good design in the 3D CAD model, but they realize that, and they feel that they have finished, strictly speaking, they have finished 80% of the work, but they think the next 20% I can take it easy. But the problem is that time-wise, it has only taken 20%. And to complete the product, you need another 80% of time. So let's say you've taken 3 months to complete the design. Strictly speaking, you need 5 times that, 15 months to complete the design. And in Indian context, it's more important because getting things done is not easy, especially one-off components. And the next slide, please. So I think you also can do this, and this is what can keep. I'll stop. This is my last slide, actually, I think. And this is something that we need to realize, all students, and I mean, at some point even we do these mistakes. With age, you realize you don't make these mistakes very often. But even I have gone through this phase. So what we do is expertise. We need a threshold of expertise before we plunge into making a product. So students, the first thing they do is go to Google. And if Google doesn't have an answer, what happens? They get depressed. Students have come and told me, sir, I'm depressed. Why? Google didn't have an answer. Well, if Google doesn't answer, that means you have to feed Google the answer. That is a challenge, you know. So anyway, so they go and they read a little from Wikipedia or whatever, and they believe they're experts. And they start implementing. But in practice, there is a huge seeding time required before you put something into practice. And then you'll have a slow growth and you will reach the threshold in some time. But if you go into this track where you imagine that this is my expertise and plunge into making the product, at some point you will see that you have failed. And then you have to come back to rock bottom and again start. And if it is a startup company, it is very critical because by that time the funder will not be there because this time is not linear. I have seen many startups who get a team and start, do. It doesn't work. It simply doesn't work. So when you are aiming for a startup or even when you are job or everything, when you're asked to do something, you take up the challenge, but spend a pretty large amount of time seeding interest in it. And then you will reach a threshold of expertise. And later on in life, like name sir? Venkatesh, I like him because he looks, his first 4 inches looks like mine. And, I know he says he lost his sleep and all that. The problem if you lose sleep thinking about design, you know what's going to happen. You lose all your hair, not only sleep. So anyway, so I think Venkatesh should have reached this stage of where he can do it fast. Just sheer experience and things. Do not take shortcuts. The next slide, please. Yeah, there's two more slides. I think. Yeah, the 3 pillars of development. People talk of social, environmental, economic, and sustainability is on the top. But actually, I would believe as next slide, please. As we go on, the environment becomes the foundation. And any product, if you take, I would think they are all harmful for them. How do we move on to creating products that when you dispose or you recycle or use doesn't create a problem in the environment? It's a very critical thing. Sooner or later, this will hit you hard. My generation may not face this because either we will be dead before that, but your generation will certainly have to face the consequences of this. And the next generation will still have a worse problem. So please keep this in mind. If they exist. That's true. So this economic, social and spiritual, I would put spiritual also as one of the pillars that is required, and then only you come to the stage of practice. So thank you. Next slide. Thank you slide.
Right, I have no intention of, so I missed out on sending the slides, but I'm glad that I missed because we got the gems out of you in a very short time. What is interesting, and again, I would say notable, so this entire slide, as he said, was made right in front of you, right? So this kind of presentation with this kind of approach with that clarity can be made in within sitting in a session, listening to others, it's still doing. And we know, of course, how much time you get for your presentation. So, time to reflect, right? So with that, I'll sort of invite people for questions. At the moment, we'll take a Q&A before we move to the next part. So please raise your hands and we'll take the questions from there. Okay, so please raise your hands and if you have a directed question, please point it to the speaker. If you have a general question for all the speakers, that also. Nobody has a question. Wow. That's very interesting. Okay, I'll give you a minute to think about questions. Yeah, please.
Just get out of this and put it in Teams.
Sir, within such a short time, how could you achieve this presentation? Because this gives you the amount of learning, the AI and LLM and all the results will give it.
See, AI, ML is what you need intelligence and learning. Need an artificial and machine. I'm not saying I'm intelligent.
Natural.
It's something that you
The happiness you are.
imbibe over a period of years. Even I started off as a bad teacher, but over a period of time, I don't use PPT in my classes, no notes, nothing. I used to take the design course here, but now I take part of the manufacturing course. It all comes with over a period of time. It doesn't happen over time, and I think you have to put a conscious effort. That's exactly what I'm saying about design also. You have to put a conscious effort. Don't ever think that you will become an expert overnight. And please write down the point. I think you can share this presentation if you want with the people. And please write down those design points. Maybe you can add to that. Sorry, but every day morning when you get up, you please, or evening when you sleep, please have a look at these points. Recently itself we were helping Kirloskar design some compressors. And finally when they did everything very well, and finally we asked them how we could assemble it. Then we realized we could not assemble it. They told they have done it, but this thing, and then, of course it's not a big problem, but you have to sort that thing. So please keep this in mind. Morning or evening, spend some time reading about this. You can read any philosophical book or when I say philosophy, design philosophy and design philosophy. Several things will give you ideas. Keep those ideas. Understand them, analyze them. It's a process. It's not something that comes overnight.
That's very nice message. So reading like a morning, early morning, it starts with that.
Good evening, sir. My question is to you. Can you talk more about the spirituality pillar towards happiness?
Same thing, spirituality. You either
Like, how do students practice it?
don't practice it. That is exactly the point I said. Like I told you, smile. Don't practice it. It should come involuntarily. Realize when to smile. Because everything, there are different times you should do different things. So philosophy, you read philosophy. I don't care if you read the Quran or the Bhagavad Gita or the Bible or Guru Granth Sahib. Everything is 80, 85%, 90% same. Finally tells you how to be a good human being. Understand? Read it, keep reading it, maybe sit and analyze it. After slowly it becomes a part of it. It's a very slow process. For people like me, it is even slower because I started late. So please, that's how you become spiritual. But please don't become a Swamiji or something. Sannyas. You have your duties in life. Just do that. Never practice. Imbibe it. Design also never practice. Imbibe it. Understand it. Practice should come involuntarily.
My question is for Mr. Venkatesh Prasad regarding the e-trike bike folding bike they made above. So I wanted to ask how you work with the folding mechanism and the electronics behind it, like the charging point, and if you could explain a bit more about it.
Okay, not this one. Okay, but anyway, see, it's not a well like a process-oriented design approach. It was a jugaad, because I wanted to do in a short time. So in that case, I purchased a lot of standard electronic parts hardware. So and only the mechanical structure I built and I assembled. So however, it's a multidisciplinary, and if you want to mass produce, you have to engineer everything in-house. Right? So that's.
Thank you, sir.
Right, if no one else is asking, I have one more question, which is, so you're working on 135 projects, right? 115 patents. Yeah, I'll ask. Yes. So when you have these many, and then of course you're working in, so typical, the general impression is that when you're working in industry, you don't get a lot of freedom to innovate. I mean, that's the general perception, right? So, and when you have done this and then you have done your side projects like these, so how do you manage your time for the side projects, which you said is Jugaad?
Yeah.
But how do you sort of switch between these two and still, because the part which I'm coming to, because you mentioned that in each of these, you actually get into details of manufacturing, doing all of that, right? So if you could just throw light on your managerial skills on time management. So
Well, that's a tough one, you know. It ends up with talking with my wife because the family time is also very important. So, but still, you know, I mean, the way I have done this is it's not my only. I'm not the only one person doing this. So I have a small group of people. We have an imagination station. So we formed it and we meet every once in a week. And then the goal of this group is to come out with new ideas every time. And we collectively, like 2 to 3, 4 people, we together work on it. So we share, and I want the young people to learn. I don't want to go to a machine shop and get it done. So some basic, and you know, involve the younger team and get these things done. Yeah. So I want to expose them to manufacturing. So that's the goal.
okay, related question is very important for the, how often do you do 3D printing?
Yeah, very often. I mean, I used to very often. The reason being, you know, now the time, as sir also told, the time to market is very fast, right? So in 1 year, you need to completely bring the product to a mass scale, like a production scale. So your design phase, your proto phase, then your engineering validation, your pilot validation, all this takes time. So you have to fail early and often. You have to fail early and often. So the more you fail, the better the product is. The planning is done better. And I used to print a lot every day. Like today I will design, tomorrow I'll get it printed, validated. So that's the approach I take up. You know, that's very useful, I think. But your product doesn't have it printed. No? These are industrial products. So there were some industrial electronic products, consumer products I worked on. I re-engineered the biometric hand reader, those kind of products. And I worked on a lot of machine SPM development and all those things. A lot of toolings. I also used to 3D print. Like I had to validate some of the things. I will quickly design a tool, validate the product in the tool. So those kind of things I used to do. So for validation, yes. And also re-engineering. The product, one of the US product I worked for 2.5 years. I had a 3D printer attached to my computer. 10 years, 15 years back, and I had to re-engineer the whole product because the supplier who was supplying this product went off for some reason. So the documentation was different. So we had to re-engineer the whole thing. We scanned it and we sent the parts to India and we scanned it, and design was generated and it was supplied to me, and I validated through 3D printing techniques, you know, on the initial, and fine-tune the design. Those kind of things also.
Yeah, so I'll just give the context why I asked this, because for students, the design is done, so everything is only 3D. There's no thinking beyond that on manufacturing. I mean, that seems to be the correct story. So I just wanted to bring that up so that they recognize that, you know, there's definitely a role for 3D printing, a very important role, but that's not the end of the story. That's
many examples are there, but I'm just telling few of them. But of course, the metal parts are metallic parts. Right? So, I mean, most of the things, high precision products, you cannot probably 3D print. So you have to go with the traditional approaches of manufacturing. But many things can be 3D printed and evaluated.
Thank you. So with that, I'll ask another question to Professor Karmakar, which is so the device that you showed towards the end, which had the those 3 legs, and what's the update on it? So is that something, if you were to take it to market, what do you see the journey? Is it already in the market is the first question. And if not, then a product which is now developed to that stage, how do you see something to be, what do you do from there on to take it to the market?
So this is very common question for all the academicians, because for our master's project, PhD research, okay, so many products are coming out, and ultimately the transfer from lab to market, that's not happening. And what's the reason? So answer is no, first answer is no. So it's not being commercialized, are not being used. But in other cases, when you have developed some product targeting some specific companies or specific stakeholders, and they have taken and they are using, but again, not for mass scale production or distribution. So in this particular case, this was a part of doctoral research. When the student left, no one is there to take it forward, because this is just a minimal viable product only to demonstrate your concept. But after that, okay, as all of you are mentioning, that is very much true, that when you are thinking about the manufacturing, then there are so many other aspects are there. So someone, whoever interested, then we are ready to technology transfer. After that, if they want to modify as per the requirement of the industrial process for manufacturing, then they can proceed forward. So now I am looking for, if some person is interested or some company is interested to take it forward, we are ready for technology transfer.
Thank you. So Professor Balaji, one question to you, which is, so you have got 4 games in a reasonably quick time, as you said. So how do you validate the learning and validate the suitability of these games?
Okay. Yeah, so as I said, yeah, thanks for bringing that point. And just to reiterate, in the interest of everyone, so all this, I was not trained in games. I was not trained like everyone are in games. I just started, I told this to Vishal Pehle, that I committed to doing a summer school last summer, 2023 July. And all that I promised and committed was to do summer is in the spirit of fun. Summer is a play time between 2 academic years where children generally tend to have free time to enjoy. So my take was, how do we make it active, experiential, worthwhile time where they play some games but yet learn some serious lessons for life, right? So I committed to it, and then working backward in 6 weeks, I worked with a lot of different industry researchers across NGOs and public, NGOs, as well as public-private, researchers and practitioners. And then we came up with these 4 games, and this was last summer. And ever since I showed you a global chart where I took on and I tried to, find out various ways in which I could go deploy it in, let's say, in university settings, educational settings, and also in industry and other forums where people are really looking at pushing the boundaries of society and research and innovation. So for instance, in one of those workshops that I did in Norway, Smart Innovation Norway. So they are researchers and scientists working on the future of energy in Scandinavian markets. So they are looking at tools like this. How can it be a collaborative tool to look beyond what comes in the future? How can we collaborate beyond disciplines? So these are some examples. And again, in Indian Army is looking at how do we shape and mitigate the carbon footprint of cantonment ecosystems. So they have embarked on this ambitious net zero transition of the cantonment itself. So how can we see thinking into them to look at materials and sustainable practices and looking at policy which might come in future? How can we future-proof designs today, right? So that we consider them very early in the design phase. So how can we use tools like this to stimulate? So the idea is to answer your question, I've been taking it all over different places and different forums that came my way, and I've been trying to test it and take also feedback, through post gameplay reflection, questionnaires and things like that. So far, yeah.
Right. Thank you. Thanks, Balaji. So with that, I'll now move to my part of moderation, which is to ask questions. And we'll start with you because you're already on. So and you already started with a disclaimer that you have not been trained in design, but then of course you are involved in game design now. So my question is that as you are involved in the process, and of course you're working with designers as well, how has your understanding of design evolved over this period of time? From starting with some notion of design which you come out from a college to when you become, have a journey and then you develop that understanding. So if you could briefly reflect on that.
Okay, so briefly, like 15 years ago, I'm an engineer, electronics and communication engineer, microelectronics engineer later. So I started my career, with designing electronic systems for automation apply to built environment and driving energy efficiency, sustainability, etc. Right, and that's how that's where first I was introduced to design also, and I started practicing design by rapid prototyping and deploying it in various environments, real environments as test beds. And there were a lot of failures we learned, and I also understood, the applications of it in various environments. And of course, formally later during my doctoral research, I got to introduce about, how do we design systems for buildings, and services in buildings? How does it impact environment, micro, macro? How these things from, macro perspectives can you, draw inspiration and design, your buildings as systems and engineer them for future and also for various stakeholders. So this is how it gradually developed. And now I'm also looking at expanding beyond the scale of buildings to urban systems, and how do we drive, and what comes to as urban challenges, how do we work taking forward, these ideas. So I think that's largely my journey has been, and as a designer, yes.
Thank you. Professor Karunakar, same question. So you have been teaching design for a while, and you're at design school, and so same questions. How has the journey been, and how has the understanding of design evolved over these years?
Yeah. So initially, okay, first I want to mention that as when I joined, mainly I was ergonomist or human factor specialist. Gradually over the years, I learned design, and then you will ask who was the teacher. So teachers was both the students and my colleagues. So regularly I start watching their projects, their presentation, and day to day whenever I am teaching ergonomics and whatever assignments I am giving them and whatever output coming out, and side by side my own learning. So when I initially used to discuss with the students and whatever activities they have done, so I found at that time, 10 years or 12, 14 years back, skill was more important for them. But after that, gradually it is shifting more skill and creativity now, because the creativity has already been taken over by the AI. And now if I give any assignment, next day they are coming with 10, 20 concepts, how they are developing those concepts, everything is using generative AI. Now, so what I feel nowadays, okay, what is becoming most important, so we cannot ignore AI or these different types of tools, but what is important for the design students to, obviously they should imbibe those AI related skills and properly use them. So appropriate input should be given so that whatever output they are expecting, that can come out nicely. And further, I think, okay, obviously sustainability, okay, when we're talking about carbon footprints, these aspects are important, but most important for the designer and what is very much required for today's designer or for today's students, that is design ethics. And if the ethically they practice design, they develop the products or consume the products, then automatically other aspects, like when we are talking about the data management, privacy, security, or say we are talking about the sustainability, all these aspects will be ensured.
Thank you. Same question.
Yeah, the initial years from 1996, I started, in a design company in R&D. So I developed close to 40 products there and 17 new products. They are running even today in mass manufacturing, mass production, earning revenue for them. So the focus was machine tools. So it was mainly, the users are operators and the function. It was very simple. So, but it has evolved, right? Nowadays, we have the end user was CNC programmers. So now you see my robotics products, they are evolving from second generation to third generation to fourth generation, which I showed there, intelligent robots. Now it's a fifth generation is also coming, like robots working with humans, or co-working with humans, right? So the technology is evolving, so the expectations of a designer are evolving. So you need to, but the basic things have not changed. So when I, considering like the tools I used, I started with drawing board. 5 years I used to do drawing board, and for me to generate a design, it's like 3 views and some sectional views that creates my design. So then drawings, I used to, for A0 size drawings, 5 days I used to make a drawing myself, and 6th day I would ink it. So that experience gave me a lot. Even today, I'm practicing it. not in the to that scale. So I started using computers from 2000. Things became exponentially fast. The A0 casting drawing, which took 6 days, is within 1 hour now, right? but you miss it because in a computer you do aeroplane is also same in the same frame, and your small pencil design is also same. So you have to have that feel. What is a millimeter? What is a metric meter? So that feel you have to have it. Otherwise, you cannot assess your design. So that's one aspect of it. And then, as I told, like 3D printing also the technology has come. It has strengthened. So now, currently, my current things I'm working with external country people who don't know English language. So how do I have to convey my design ideas to them? The designers are working there and they deliver me the design. So that is by through sketching. So I'm practicing that sketching. I never forgot that. So that is very, I can, even today I can read my, blueprints. So that has gone to many great extent in many of the engineers nowadays because of the advent of computers. So I think that is a very much good skill, and they understand. No need for English, no chat, very little text chatting. They convert and understand, and they communicate with me in 3D. And then I again mark up on the computer. This is how we have to do. So that's how I manage. So that's, but still we get the quality design. That's how. Big question.
I don't know if I am a great designer or anything like that, but I should say right from my engineering days, we have been designing things. In fact, our project in engineering was to make a cylindrical parabolic solar collector, which could theoretically boil water. Nobody believed it could boil, and there was one classmate of mine, who was making fun of the product. So I told, put your hand on the other side, and I proved from that side. Heated steam hit his hand and it burnt. So we had to nickname him Bernal. So projects were successful, and I think the philosophy of design actually took a big turn when I became faculty here. There was a lot of things that we simply don't appreciate. For example, Dibakar's ergonomics and things like that. Because it's more to mechanical, but Amresh, for example. There were times when we used to have joint interviews, and so there will be faculty in mechanical engineering. So CPDM and mechanical engineering used to have a joint interview panel. So mechanical engineering faculty will be asking very serious differential equations and partial differential equations. Then Amresh will ask for question, take the paperweight and ask him, tell me 5 uses of this. So faculty other faculty used to get upset. I am trying to get off this mathematics skill. This guy is just taking he says, I want to take the paperweight and hit your head. So we realized that CPDM should become a separate entity in itself. But I should say that design and approach to design and all these things were basically through CPDM being exposed to several things that you are never exposed to in life, and also teaching the course, material selection. That really helped me change a lot of the way you do design. As far as products are concerned, in my lab, even if you have time to come to my lab, all machines have been designed for specific purposes. And we don't buy commercial machines. When commercial people come to sell me, I tell them, sell my machine. But I'm not going to buy from them. So we are built that way, and we are doing things differently. Thanks to CPD.
I think the same question. So I think you have already answered the second part of my question, also included in it, which is, as you said, CPDM was a key turning point in some sense in expanding your design. So similarly for you, any notable, say, incidents, people, projects that change your view on design? Sure. Maybe I'll ask. Okay. So whoever is ready with the answer. So I think Bala or Professor Sagata, if so, the question is any notable incidents, people, projects, events, something that changed your understanding of design significantly.
Yeah, so okay, I want to mention one, as I was earlier also mentioning, that particularly minor in product design course. Okay, in that course I really realized that, because earlier I used to think, okay, probably there is not as such difference between the engineering students and design students initially. But when I took that course, product design and minor, then I realized some difference. So what is the difference? Just giving one example. So in the class I gave one assignment, and that was very interesting for me. That's why I'm sharing. That assignment was related to that you have to design a mobile phone holder, and that holder should allow you to see that mobile phone. So like I'm holding like this, and I can rotate it, I can set it at least in 3 different angles. One is, say, for example, with a vertical 30 degree, another 60 degree, another 30 degree angle. So that as per my requirement, at least this 3 angle I can set, and accordingly I can see my mobile phone if I am watching some movie or whatever. But if you can make it continuous, not discrete, continuously from 90 degree to 0 degree, that is great. Now, after that assignment, students come up with some concept and also some mock-up. So how the concept was different. So that was amazing. So all the engineering students, they came up with gear mechanism, so many screw and so many nut, and how they can rotate it. But on the other hand, when design student came, they have come up with, I can show those products, okay? So just one bamboo cut out of bamboo piece, and there are 3 grooves, 3 different angles. That's all. Okay. Otherwise, they have done one platform, okay, small platform where they can attach that mobile holder, and just by one rotation, they can set at a different angle. So the solutions are completely unique, and both the solutions, I'm not telling that, okay, the solution of the design students was better than the engineering students, but the way of thinking, the approach to solve the problem was completely different. And also, as I mentioned, because I could not present another part of my presentation, where many a times, okay, when we go for this type of projects, and students think that for a particular problem, only one solution is possible. But in reality, we have to think that for the same problem, one of my students worked for the same problem, for different scale of production, different scale of industry, 3 different levels of solutions are required. And more interestingly, the same solution, if I just scale up, make it bigger, it cannot be adopted by another level of industry as per their production. So I'm talking about the requirement of the industry, but same for the consumer products also. Say, for example, one product, I am developing one fruit sorting machine, electronic product, based on the image processing. That product will help in fruit sorting, but you have to see what the user, what the going to buy that one. Is it for household purpose? Then your product design is completely fine. Is it for the food processing industry? Your design is completely different. So you have to understand the context, understand who are going to use, what's the cost constraint, okay, manufacturability, all these aspects. Otherwise, only getting the problem and thinking the solution, it will not work. So I think these are very great learning and great understanding from doing all these projects.
Thank you. Thank you very much. Balaji, same question.
Yeah. So I have 2 important episodes or event that has profound impact in the recent years, right? So number 1, I think I would argue me, me living in Denmark and being a researcher at DTU has profound impact, and I would like to share the instance. So me as a researcher, the first day, meeting as a staff, the provost or the president of the university, he addresses all the people, and this is a message that is profound to me at least. I've not heard this principle and ethics of work. And he says, anyone who is working, do not waste your time if it doesn't have any impact in impacting life of people and social impact, right? Do not venture into anything, waste your time writing publications or products or innovation that you're doing that has sheerly, something that for your own sake. Because we are public institute, we have we are spending time, money on your salary or whatever, it has to have impact social life of people, right? So that's number one, which has got a profound impact. And I'm trying to see, I mean, Asian, largely, it's sad to say that, but most of our innovations and things, and also in the educational institutions, our work and things are tied with publications and promotions and so on and so forth. So I do not really agree to that. I differ from that. I also say that we need to think about impact. So that's where I start from my research with impact, and what if I mean, at the end of my life, let's say next 30, 40, 50 years of my professional life, if I could, have my work impacting, 2% or 1% or 0.1%, I think I would be happy in shaping the future of the planet, and also the, cities. Cities is what the scope that I've taken. Number one. Number two, I think I also agree with Professor Satish's point. It's only me in my educational endeavor, the recent one with claim, when I started becoming a teacher and an educator, I started thinking deeply as to how do we communicate and inspire the next generation of youth and working professionals to be really prepared for challenges of this century, right? And this made me to think, how do we communicate these complex problems? You can communicate it very simply, with slides and videos or documentaries, etc. But it has to hit really the heart, right? To see, to draw the inspiration from, to think about the philosophies and why are we doing the things, why we should do that, and how should we do it, and how do we really play a part in meaningful contribution to this planet and the society, right? So, and I think being a teacher is another profound impact in the way that I started thinking and designing these tools, and exercising them as aids in my classroom, as an educator. So I think these are the two main points that I would like to iterate.
Thank you very much. And the same question.
Yeah, the initial foundation years for me, right? First 5-6 years I worked in machine tools in very, very high precision, like 1 micron, 2 micron accuracy products. So that, made me a lot. So because you to make one machine, for example, I'll quote an example of CNC grinding machine workhead. The accuracy is less than 1 micron. To make that, you have spindles, you have bearings, you have castings, housings. So everything, the spindle if you take. So you have to do CNC turning, then you have to do stress relieving repeatedly. Heat treatment, grinding, rough grinding, finish grinding. Why all those meticulous steps to achieve that 1 micron, less than 1 micron? So I created several products like that. So roundness checking machine, turrets. I was involved. I'm not the sole. The design was done. I was fresh out of college. I'm not saying everything is designed by me. So I learned all those aspects. My leader, he was a global lead in machine tools. So I was very privileged to work under him, and I got all this experience. So why I'm telling all this is, after I joined TCS, I got varied projects. I worked in forklifts. I worked in consumer electronics. So I lost some of them. According to the customer needs, we work, right? But the basic thing is, I never forgot the foundation, the initial years that you develop. So it made me, when I went to one US customer, it was a global lead in bearings and seals. I was in charge of that as a test engineer for the lab. So I was supposed to develop several SPMs. So my precision experience helped there. These were machines of 6,000 RPM, at same accuracy. After so many 10 years of, I lost touch, but still I made it happen. That satisfaction, that confidence you develop. So those are some of the things. And even today, I'm working on submicron accuracy parts and miniature parts. Now my focus is on small products and of that accuracy. I can't even see. I need to use a microscope to see. And I have an assembly of parts, and it has to work in a certain way. So all that, background that you develop over time makes you a very, very strong engineer.
Right, thank you. I think this goes back to the point that Satish was talking about, is the expertise, build the expertise, and at some point it starts to. So with that, I'll come to the last question in this round. I'll again start with maybe Professor Sagata, which is, and you already started with that, so in terms of you brought in Gen AI and all that. What do you see as the next frontier in design from your perspective? Design research. What is it that sort of looks most attractive to you?
Yeah, it is very difficult to tell, okay, because we are really uncertain that what is going to happen after this AI, and gradually whatever is happening, particularly as I mentioned that design ethics part, because not only the product design, but in other sorts of design, like particularly UX, what is happening related to data, and when you are going for big data handling, the data privacy, security, all these aspects are coming. So in that scenario, I think we have to be more careful, particularly we have to think about what type of law or what type of regulations we can implement, so that when designers or designer practitioners are developing different designer output, those should be ethical, and at the same time, it should also should not impact on our daily life, particularly from the perspective of sustainability and its all three dimensions of economic, social, and as well as the environmental.
Right, thank you. Same question, Balaji.
I think, yeah, so as an urban futurist, I'm also trying to follow a lot of these trends that are shaping the future transition pathways of cities, economy, policy making, and etc. So I think it is very, very important at this time to embrace multidisciplinarity, and it is time and again many global surveys and studies show that having and fostering and developing this sense of lifelong learning is very, very key, right? You can because the transition time is really quick, and you need to really adapt to skills very, very quickly, and otherwise you're out of the game, out of organization, etc. So you need to cultivate a heart and attitude to be able to learn until you die, right? So that's one of the critical 21st century skill to have. Number two, as I said, multiple disciplinary critical reasoning and thinking skills needs to be central to shaping the future. And of course, talking about AI and digital technologies that are emerging and shaping our lives, I think one of the greatest risks, this is what philosophers and futurists are looking, that will have a profound impact on the civilization and human extinction, perhaps, right? So we have, a tremendous, what do you call, risk lying ahead of us in terms of digital transition, digital technologies coming into our life, right? And how do we really shape? And this requires us to think about governance, regulation, and we need to have a global governance, right? So it's not just you designing regulations for the country, but we are now talking about data, which is going beyond borders, right? And we need people across borders, and we need to create laws where we see, there should be all the nations coming together to sign these kind of agreements together. And we need to really, as Professor Sogarate says, we need to also, as designers, think about principles, ethics. We need to have a strong morality and values embedded into these things, right? So only then we can work together towards us safeguarding the planet and also the species and humanity. So digital disruption is one of the global risks that we are going to face, and how are we going to overcome is a really big challenge, and it requires us to embrace this, not just the positive sides of the technology and advancements, which is what we see that it can bring benefits to our life, but also look at 360 degrees around innovation and developments and growth that is coming, shaping us, but also look at the risks governing it, and how do we rather develop a community and resilience around this future. So I think that's key for us to think what can shape the future, and what kind of aptitude and attitude do designers need to cultivate. Yeah, so I would just stop there, Vishal.
Yeah, thanks, Balaji. I can see the flame in you, so it's good to see you at flame.
See, what interests me a lot is a lot of technology is getting not a lot, I would say some of the technology is getting transferred to India from other countries, right? So my area of interest is like, our India is known for software focus and less of hardware focus. So I want that to reverse. I would like to work in the areas where we can make our hardware strong, and our design and manufacturing in India should increase. The dependency on other countries should reduce, and more increase in India should happen. So I like to take up those kind of challenging projects. Be it
You've spoken the golden words that we hope somebody speaks in this department for students.
For me, the future is sustainability. Whole foundation should move towards sustainability. But in certain areas, you cannot even think of sustainability. For example, defense. A sustainable weapon would be a nice sword and a knife. You can't have swords and knives these days. So there are issues, but I think imbibing the thing that sustainability and simplifying life is a very critical thing in the future. Design approach. That is going to define what the world is going to in, let's say, 100 years from now. Because I've been in a generation where I've seen my grandfather's house with no electricity, to everything being done manually. So today, even in that same house, they cannot live without electricity. It has come a long way. In a way, you can say it is developed, but you've become over dependent and interdependent. There is a point where it might reach a breaking point, and then what? So that is something that is critical in this sustainability. Like I showed the figure, that should be the foundation. Build the rest of it. Thank you.
All right, thank you all very much. I think with that we come to the end of the panel discussion as well. If anybody has any questions, you have the last opportunity to ask last two questions, just in case you got some good questions in mind in between. If you don't, then I believe you are looking forward to your dinner. Either way, I have my answer. So I'll give a pause for a minute. Are there any questions?
When all the panelists Can all the panelists just quickly suggest one book that we all should read?
Right, that's
Just
that's
one.
a good-
Not more than one.
One difficult, it's, are you a Hindu? Then read Bhagavad Gita. I'm correct in guessing.
One. Right, there you go.
Dr. Balaji, show now one book, please. Speak.
So, okay, no, I'm just holding a book in my hand just to show in case some of you have already read it. It's one of the best-selling books, and he's a philosopher, a futurist, a historian, whatnot, and from Israel. And he has written a book on how do we survive 21st century. And and there are 21 lessons, profound, and some of the ideologies that I just shared are from his philosophies drawn from him. So I would recommend some of you who are looking at setting your life goals and ambitions, as young careers when you're starting. I think we should all read this and draw some inspirations also as to survive the century and shape our work ethics and whatnot.
Thank you.
Good.
Yeah. Okay, whoever starts, so either you or Professor Sagata, one book from your end.
No, I don't have any books in mind, okay, that which can be very much beneficial because all the books have different aspects and all are important, so I cannot mention a specific book.
Same answer.
probably.
Well, several good design books. We can't really, that's why I told you right in the beginning. Yeah, you have to read a lot of books in the Bible.
You can read Google.
You read the book Zen and the Art of
Show many books.
You read that. They're all in between philosophy and scientific research. These are the books that make you think about it. Jonathan Livingstone Seagull. Yeah, Jordan Livingstone, Seagull. Seagull, then Outliers. Outliers are very good. Yeah.
See, for designers, like I used to refer handbooks, CMPI handbook. It was my Bible to do anything. Maybe you are also referring.
I don't think that they are gone.
No,
We used to think in 2D, they all think in 3D. They can't. Very few students can draw a 2D figure. Automatically goes to 3D.
See, because these handbooks, see, you get everything in Google, right? So I still don't recommend that because it's like country-based standards. If you're in US, you have to refer American missionary handbook, or if it's in inch standards or metric standards. So it's all things, right? But that really helps you because you're not deviating. Google will give 10 results, but books will give only one result, which the people in Bangalore, for example, Kenya, they follow it. So that's the way you should design. Not rely on CAD. Even CAD is giving, lot of inbuilt, for example, screws. You have to, the thread size, all this pitch, everything, but you don't know what to choose. So best is handbooks.
But that is, yeah, but my point is that okay, if really there is a book and that book is very much helpful for all the designer, then it would have been great because then no need to search Google or no need to read so many books or explore so many things. One book is the solution for everything. So I am expecting that this type of book should come in the future.
Right. So,
It will not come.
so on that point, I'll move from the book to a note.
Define it, please.
Right. So that, thank you all. I think it's been a wonderful session. Very different 4 talks, and that's what we expect in this kind of session. So with that, I'll invite Professor Swain to please come over. So I'll give the context again. So these are now 4 design ambassadors from CPDM and
Before we do that, I request you to make an announcement that will circulate on Google form for all the students.
Yeah.
They should write down few points from here. Okay, those who attended and those who did not attend, what were the 3 reasons they did not attend?
Right. So you heard the question, right? So those who have attended, they need to. So I'll circulate a Google
First
form.
point will be yes and no.
Right.
Okay, those who said yes, they should write 3 points that they got from this interaction.
Right.
And those who said no, they should have 3 reasons why they did not attend.
Right. So the first part of that is let's get the attendance sheet running. I think we have already done that. Wonderful. So now I know at least that who all are here. Okay. So with that, so you have already heard it. I'll share the Google form, and as you said, you will check whether you were on your mobile phones or were you listening, because they share. Because I noticed quite a few mobile phones. Right. So okay. So that's the part which is on the side note. With that, I'll sort of again, as I said, we'll close it here. The idea here is that we have invited, in each talk, we invite 4 design experts. And over these 25 talks, we'll have 100 design experts who have spoken about design. And we'll end up with a coffee table. So that will be something that we'll have available. Of course, all these talks are going to be available on YouTube as well. And we'll also try to, at the end, compile these talks to create a documentary sort of thing so this coffee table book, of course, will be available to people. And part of the idea is that these are our 100 DM ambassadors who go on to talk positively about the department, and criticism they can come back to tell us what is to be improved. So thanks again for joining us. Those who are online, they have to come here to collect their certificates. We'll get it to you, don't worry. So please, I'll invite Professor Singh to hand on the design ambassador certificates. So at this moment, it will be ceremonial. The reason being that we haven't got the signature of the Chakravarti yet. So we'll do it for the photo station. We don't even have the names, but that's all right. So I'll invite. We later on anyways need to do the names and the signatures like that.
Then if you take photo, it will say no.
No, I did it.
So thank you again, sir, for coming.
Thank you for
And for the wonderful talk.
So big applause should be there.
Yes. Big applause, please. Yes. Thank you again. All right, so for Professor Sagata and Professor Balaji, we'll get your certificates to you.
Thank you all.
Yeah, thank you very much.
Thank you all.
And, yeah.
Oh, he's got his kid there.
Yeah, and great to see Balaji, Balaji Junior, right? Yeah. Thank you. With that, I will close it here. Thank you very much.
All right. Thank you so much, everyone. It was lovely to take part in this and listen to some of these experts. Very nice, and let's stay in touch.
Yeah, thank you very much. Yeah, we'll stay in touch. And we'll invite all of you for longer sessions. All right, so the next Silver Jubilee talks will be on 13th, and the next one will be on 27th, right? And then now you already know that we are going to take attendance, and we'll take attendance sharp at